Hello 20-1 students. So we are looking at our last part of our last lesson for this chapter. So carrying on with the quadratic formula, which we started in the previous lesson. And today we're going to look at basically expanding into a little bit more complex types of questions with the quadratic formula. So just to get started, let's remember basically kind of what we've done in this chapter so we can think of all the different ways that we have to solve a quadratic equation. So if you remember, we started out with a review of the factoring that you learned in Science 10 and then kind of carrying that over into how we can use factoring for polynomials. The other thing we looked at was being able to complete this square. So that was our next set of lessons. Complete this square. Of course, the last time we started looking at the quadratic formula. And basically throughout all of these lessons, we've used graphing on our calculator to either solve or at least to confirm our solutions. So just always remembering that we have that to check our answers. Next thing, just a quick reminder, what are the three scenarios of the nature of roots? Okay, so what are the three types of roots we can have? So if you remember last time, we kind of looked at three main options, and if you remember, we talked a little bit about the discriminant and how the values you get for that, whether they're positive, negative, or zero, are going to indicate the number of roots. So with roots, we can either have two roots, so it could be something kind of like that, and all that means is that the graph crosses the x-intercept at two different points, so we have two roots. Okay, now if you were writing this on a test, because it asks you to explain the nature of roots in words and with a graph, you would want to maybe say like two roots or two x-intercepts and then sketch out the idea of the graph. Now remember, for any of these, you can have the graph either opening up or down. Okay, so that is not relevant to the types of roots. The other option we could have is no roots, and that's where the graph does not cross the x-intercept. So again, you could have something that looks like that. So we can see that the minimum is above the x-intercept and it's never going to cross it. Or we could have something that's opening downwards, and again, the maximum is never going to reach the x-intercept, so no roots. The other possibility is that you have one root, and so that would be where the vertex of the graph, whether it's opening up or down, is just going to touch the x-intercept. And basically that's the only point on the graph that will come in contact with the x-intercept. So we say that that is one root. Okay, so those are our three different scenarios for types of roots. All right, so that was just a little bit of a refresher from what we've done so far. Now let's look at solving kind of more complex word problems with the quadratic formula. So Sipapu Natural Bridge is in Utah. Find the horizontal distance in meters across this natural arch if it is represented by this equation. So important to kind of keep in mind the visualization. If we have an arch, we know that the shape is going to be kind of like that. And we're looking for the horizontal distance across the opening here. So remember that in terms of like a parabolic graph, basically what that means is we're going to assume that the ground is the x-intercept, and whatever our roots are is going to be the two different points of the arch. So remember, we need to find the distance between those two. So first we need to find our two roots, and again, when you look at this, it looks like a reasonably complex number, and so quadratic equation seems like a nice easy place to get started with this. So we want to assign our values. A is negative 0.04, B is 3.28, and C is, there's no number being added onto this, so C is actually 0 in this case. Okay, so now we can fill in our quadratic formula. So remember, it's just negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So if we plug in numbers, negative b is negative 3.28 plus or minus the square root of b squared, so 3.28 squared, minus 4 times by a, which is negative 0.04, times by c, which is 0. So actually this is all going to be 0. So we're just going to have the 3.28 squared there, divided by 2 times by a, which is negative 0.04. Okay, so basically now we just need to have negative 3.28 plus or minus the square root of 3.28 squared, which is 10.75, an extended decimal, so make sure you keep the full number in there, divided by negative 0.08. And so essentially the square root of 10.75 is of course going to be negative 3.28 plus or minus, because we got it by squaring 3.28, it's going to be 3.28 and divided by negative 0.08. So negative 3.38 plus 3.38. No, where did I do that wrong? This one, 3.28. Negative 3.28 plus 3.28 is going to be 0, so we have one root at 0. Negative 3.28 minus 3.28 is going to be equal to negative 6 point something. If we divide that by negative 0.08, we get 82 exactly. So this is a nice situation where we started at the origin, and then our other x-intercept is out at 82. So we can say that the distance between, like the horizontal opening underneath the arch, is 82 meters. Okay, so again, check the filled in notes for the proper way that I would expect you to answer it on a test, because for a word question like this, you should be writing out the horizontal distance is 82 meters. Okay, also just paying attention to the units that are given in the question when you answer it. Okay, now a lot of times what we're doing with these types of questions is we're solving kind of weird types of questions, like if 4 times the square of a number is 81, what is the number? Okay, so you're given this kind of obscure thing, and what you need to think about is how you can set up an equation that represents what they're saying here. So we're looking at 4 times the square of a number. So a number is going to be the variable, so we're going to call that x. And so basically what we have is, if you have this number squared, 4 times that will be 81. So basically we have x is going to be squared, so the square of a number, and 81 is 4 times that value. So basically 4 times by x squared is going to be equal to 81. Okay, so this is where, this is kind of a skill that's hard to teach. You really just have to be able to assign the value, like figure out what your variable is, and then kind of work methodically through what they're telling you to determine how the formula works. So just be careful and know that it's going to be like, you have this number, you have the square of it, so it's going to be x squared, and then 4 times that value is 81. So that means that it's going to be equal to 81. So now what we want to do is solve for x. Now, if you wanted to, you could use the quadratic formula here. You would just have to move the 81 over. You wouldn't have a b value, you'd only have a c value. Personally, for me, when I see this, it looks easy enough to just solve using algebra. So if I want to get x on its own, the first thing I want to do is move the 4 away. So I want to divide 4 out of both sides. That's going to leave me with x squared equals 81 over 4. Okay, and so then I want to say square root this to make it just x. And so I can say x is equal to, the square root of 81 is 9, the square root of 4 is 2. Okay, so I can either put it like that, or they didn't actually tell me that I had to leave it in fraction form or as an exact value. So if I wanted to, I could also say x is equal to 4.5. Okay, and you can always try it as well. If you square 4.5 and multiply it by 4, that's a good way to check that you had your equation set up properly in the beginning. Okay. All right, one more, so a little bit even more complicated. Leah wants to frame an original painting on canvas measuring 50 centimeters by 60 centimeters. So like I mentioned in previous lessons, I think that it's always good to start out by visualizing things. So she has a painting that's 50 by 60. So we're going to assume that that's rectangular. So we have 60 and 50. Before framing, she places the painting on a rectangular mat so that a uniform strip, and this is going to be important, of the mat shows on all sides of the painting. Okay, so basically she's putting it on a bigger rectangular mat that's going to have like an exposed edge on all sides. The important thing is that it's uniform. So basically that means we know that this length is the same as this length, is the same as this length, is the same as that length, even though my drawing might not show that. So let's call that unknown length because we don't know how big that is. Let's call it x. Okay, and so that's going to be this distance on any side of the painting. The area of the mat is twice the area of the painting. Okay, so essentially what we could think of here is we have painting area and how do we solve for area of a rectangle? Well, it's just length times width, so it's going to be 60 times by 50, which is going to give us 3,000. Our units were centimeters, so for area it's always going to be centimeters squared. And we're told that the area of the mat is twice the area of the painting. So mat area, again, is going to be the length times by the width of the mat, but we don't know what those values are, length times width, but we know that it's going to be twice this value, 2 times by 3,000, which is going to give us 6,000 centimeters squared. Okay, so that's our area of our mat. They want to know how wide is the strip of exposed mat showing on all sides of the painting to the nearest tenth of a centimeter. So we're going to be looking at using decimal values. So now we have the area. We don't know what the length and the width are. So this is where we would have to develop an algebraic formula to represent the length and the width. So if we think about the mat, if we think about the length of it, right? So that's going to be like this side here of the mat. We know that it's 60, at least 60, right? And then on the left side it has x value, and on the right side, remember, it's uniform, so it's going to have the x value as well. So what we could say there for the length is 60 centimeters plus x centimeters on one side and x centimeters on the other side, so plus 2x. Now what about the width? Well, the width is 50, and then remember the mat is uniform on all sides, so it's also going to have an x here and an x here. So it's going to be 50 plus 2x, and all of that, length times by the width, is going to be equal to 6,000. So now we have number values that we can start to work with. The next thing we want to do is, because we have two sets of brackets set up like this, we want to expand it and simplify it. So we want to make sure that we've basically combined all of our like terms as much as we can. So in order to expand it, whenever you have these two brackets, you need to multiply out using FOIL. So first, 60 times 50 is going to give us, actually, sorry, I'm just going to put down 6,000 equals 60 times 50, which is 3,000. Outside, so 60 times 2x is 120x. Inside, 2x times 50 is 100x. And then last, 2x times 2x is 4, x times x is x squared. Okay, now simplify. Just remember you want to keep your like terms together. So basically, what I'm also going to do here, because we're dealing with some pretty big numbers, so I might just want to use the quadratic formula and not worry about trying to factor, is I'm going to move this 6,000 into here to set it equal to 0. So if I had plus 6,000 there, I'm going to have minus 6,000. So basically 3,000 minus 6,000 is going to give me negative 3,000. Plus 120x plus 100x gives me plus 220x. And then plus 4x squared. Okay, so these are my three terms. They're out of order, but if I want to use the quadratic formula, this same values apply. So remember, a has to be with the x squared. So we have plus 4 for a. For b, we have positive 220, because that's with the x. And for c, we have negative 3,000. Okay, so now we want to go through and just put in our quadratic formula. So x is equal to negative b, so negative 220, plus minus the square root of b squared, 220 squared, minus 4 times by a, which is 4 times by c, which is negative 3,000. Divide all of that by 2 times by a, which is 4. And we end up with negative 220 plus or minus 310.483, something like that. And then we want to divide that all by 8. Okay, so now if we were to do 220 plus 310, we end up with let's see, negative 220 plus 310, we end up with, and then divide by 8, we end up with x equals 11.3. If we do 220 minus 310, we end up with, and then divide by 8, we end up with x equals negative 66.3. Now the important thing here at the end is always to pick which one makes sense. So would it make sense to have a negative value here as our x value? No, and so we want to choose the positive value here, x equals 11.3. Sorry guys, I don't know why they're ringing the bell like crazy here today. So then you would, and again you can check the filled in notes for this, but write it out properly. The strip around all edges of the mat is 11.3 centimeters. And just remembering they told you to round it to the nearest tenth, so that's why I kept it as 11.3 centimeters. Okay. So again, I have some practice problems there for you to try. It's a really good idea to work with these word problems because they will definitely be on your test. So go ahead and work on that, and then you can do the chapter review to get ready for your test. So good luck with that.